So we're going to talk about how to Dockerize your JavaScript development environment. So pretty much take all of the normal JavaScript that you normally be running in development and instead use Docker to run it. And there's a lot of great benefits that we will get from that. So real quick, before we get started, if you do plan on following along with any of the examples, there will be some. It's not going to be all slides. There will be code. Don't worry. You can install Docker from docker.com/community edition. That's for if you have Linux or if you have a more recent Mac OS or Windows operating system. If you have an older version of Windows or Mac OS, then you'll have to use Docker Toolbox, which you can get in that second link there. Also, all of the examples will be in Linux containers. So if you happen to be running Docker for Windows, then you'll need to go to the bottom right-hand corner, click on the little Docker icon, and click Switch to Linux containers. If you're new to Docker, I have no idea what that means. It all makes sense after about 15 minutes. Also, there's some code examples. There's two repositories here that we'll use both. So the first one is pretty much my guinea pig application that I've used for every talk, presentation, or anything I've given the past year. I actually used it for a talk last May for RVA.js. And then the second link down there is a more recent iteration. That's a full stack version of the same very simple application. Also, I'll need a volunteer later on. So if you're interested in participating, at least get that second one down there because you'll need that. Bonus points if you have a MongoDB client installed as well. So more on that later. All right, so a little bit about me. As Dylan said, I'm from Richmond, Virginia, and I'm a software engineer at Unbox Technology. I want to give a quick plug for something that we're doing at Unbox these days. So every second Tuesday of the month at noon, we host our own very small dev talk. And so you can either join us, come hang out at our cool office with us, or you can catch it on YouTube. We live stream to YouTube. So every month when you come to RVA.js, just remember, oh, you know what? Next Tuesday during lunch, I should check out the Unboxed Dev Talk as well. Also, after this evening, if you want to learn more about Docker, or maybe you've already used Docker for a while and you're interested in learning more, Unbox is hosting the Docker Richmond meetup this month. That's on Thursday evening, May 17th. You can look up the Docker Richmond meetup group for more information on that if you're interested. So a little bit about my story with Docker. So pretty much any free time I have for the weekend, weeknights, I just spend writing code because it's what I enjoy doing. It's normally something JavaScript or Docker related. I've been using Docker for about the past year now. It all started one weekend when I was like, screw it, I've got no plans. And so I just binge watched a bunch of Docker videos on the Pluralsight, and that's kind of what got me hooked from there. And since then, we've been able to use it at work for a couple different use cases, mostly in development. I've also given previous talks on this content. Some of what I'm sharing tonight is some new stuff, but you guys are the beneficiaries of my progressive iteration on this talk. So thank you for that. Also, love me some Indian food, in particular South Indian food. Makes any difference. So what are we going to do tonight? We're going to talk about three major things. So the first thing, we're going to talk about, what is Docker even, right? So I'm not going to assume that all of you guys have used Docker or know what Docker is. We're not going to spend a ton of time, but I think it would be to my chagrin if I didn't at least explain a couple of the major, more important things about what Docker is. Next, we will talk about how we can manage our dependencies with Docker, right? Because I think all of us here have had days or maybe even weeks where we spend our time fighting with NPM or Yarn or maybe other package managers for other languages. So there's a lot Docker can do to help us out with that. And then lastly, we're going to take a look at what a full stack development setup would look like running inside of Docker and how that makes our lives so much easier. So just out of curiosity, out of show of hands, who here has used Docker before? Okay, so about good number. That's good. That's good. Awesome. Would anyone like to give a very basic definition of what Docker is? Okay. We'll look at that later. We'll talk about Docker versus VMs. Any other ideas, any thoughts?
I would describe it as basically isolation for processes in terms of like network and stuff like that.
Yeah, that's probably that's a pretty good concise definition of what Docker does. Docker allows you to run things in isolation, multiple different things in isolation on the same host. The kind of high-level definition I always give of what is Docker is Docker is a virtualization technology that allows you to create isolated, minimalistic environments for a specific purpose. So when I say virtualization, it's not the same thing as virtualization with like VMs. Docker and containers are definitely the next step in virtualization, but it's nowhere near anything like a virtual machine. We'll look at some of the details later. Next, when I say isolated environments, the Docker container, so if you've heard of Docker, even if you haven't used it, you've probably heard the term container. The container is what gives us isolation. So we can run multiple different processes in their own separate container on the same host, and they can all be isolated from each other, and everyone's happy and everyone has what they need in their own environment. And when I say specific purpose, so typically whenever you run something in a Docker container, then you typically only want to do one thing per container. So Docker really helps us also kind of move away from monolithic architecture to more of a microservice-oriented architecture. You don't have to, but it really is beneficial in that way. Now, Docker isn't the only container platform out there. There are others. So CoreOS has their own called Rocket, it's called RKT, which is, CoreOS has recently been acquired by Red Hat. There's also such thing as Linux containers, which is kind of a Linux native implementation of containers. And then there's also containers on Windows. So, but Docker is definitely the most popular, partly because of their branding and also partly because they were kind of the first ones to make some changes to how we use containers to make it much more popular and much more approachable. So why Docker? Why would we want to use Docker? So there's a couple of major reasons why Docker was developed. So the first thing is it really helps us move away from the works on my machine excuse in that problem. Because using containers, we can ensure that we have a consistent environment for applications no matter where it's run. So with Docker, we can, instead of just shipping the code to some server and you have no idea what the environment is like on that server, you can instead ship your code with your environment, and you don't have to care about what the environment is of the host machine that your code will be running on. As long as you know that, okay, you can run my containers, then you're safe. You don't have to be worried about what's inside, that's it. So it makes it much easier to develop, ship, and run apps anywhere for any platform. Also, it creates a much better separation of concerns. So me as a developer, I'm primarily a developer, so if I'm developing an application that's going to go in a container, all I have to be worried about is my application, my dependencies, and whatever runtime I need for my application to run. And then after that, once I know that the contents inside my container are set up properly, I don't have to worry about anything else. I don't have to care about how it's shipped. I don't have to care about where or how many machines it's going on, because then ops can come and they can take my application that I've bundled up to be running containers, and they can ship it, deploy it anywhere they want, and they don't have to be concerned about what's inside. So it's really great to kind of create that separation of concerns. Also, Docker and containers in general give us much better use of computing resources. So previously, back in the old days, before, like when I was a kid, and before I was born, I'm pretty young. I haven't been in this profession for a super long time. So back in the day, there was always, you could only ever serve just one app per server, right? And so it was a horrible misuse of funds because servers ended up being severely underused. And then came along the virtual machine. And so then virtual machines allowed you to run multiple applications on the same server, all in isolation from each other. But the virtual machine comes with, as you all probably know, the virtual machine comes with a lot of performance overhead, right? So it's super heavy because it's got to virtualize the entire machine, and then each VM has got to have its own full operating system. And all that's costly, regardless of even running any apps in a VM. all that just takes up a lot of computing resources. The difference with containers is that containers share the host operating system, so you only need one OS on your host. And spinning up and tearing down containers is a super, super quick process, much, much quicker than starting up and tearing down a VM. Now, I've talked about containers, but what is a container? Anyone here has used Docker? Would you all like to take a stab at giving a nice definition of what is a container? Yeah, so a container is that isolated environment. But I want to go a little bit deeper than just that high-level definition. So anyone else have an idea of how you would explain a container? Yeah. Yeah, good. So let's take a little dive and see what exactly is going on with containers in the neighborhood. So containers are not actually a real thing. We typically see this meme in regards to the cloud, but it goes the same for a container. So a container is really just an abstraction of things that exist in the operating system kernel. In particular, on Linux, containers are just an abstraction of these things called control groups or C groups and namespaces. And on Windows, there's similar OS features called job objects and namespaces. So C groups provide resource limits. So with C groups, you can place controls on the computing resources that are available to a process or group of processes. And with namespaces, we can create isolation, right? So each container gets its own file system, it gets its own network stack, and its own process tree, and all this is made possible by namespaces. So really, a container is actually just an isolated slice of the operating system with resource limits applied, and that's it. It's not actually its own thing in terms of what's in the OS. Now, when I first heard about Docker, it was a couple of years ago, and I asked, well, what is Docker? Like, what is a container? And it was first explained to me as, well, it's kind of like a lightweight OS. Sorry, I don't mean to call you out. But someone explained that to me a few years back. And that's kind of a nice intuitive explanation. But really, containers are a far cry from a virtual machine. So VMs, they partition physical computing resources. They have to create virtual hardware. They add an entire OS to the machine. And it gets its own dedicated slice of disk, where a container just partitions operating resources instead of partitioning physical computing resources. And the containers actually share with the host the physical resources that are available, right? So a container could take up tons of RAM and CPU, or it can be configured to only take up a small amount. And those limits can be applied and adjusted very dynamically, unlike actually creating partitions. And then they're much quicker to start and stop. So a container is actually much more like a virtual operating system. Now, you'll have to forgive my pedantry for making the distinction, but it's an important distinction because if we only ever call containers just a lightweight VM, it kind of obscures the true value of what we get from working with containers. And once you actually get into the weeds of it, working with containers is quite different than working with virtual machines. Now, you might be wondering, well, you've mentioned, okay, C groups and namespaces are a part of the Linux kernel, and the Windows kernel has job objects and namespaces. But you're using a Mac, so how in the world are containers working on a Mac, right? So there is no such thing as a native implementation of containers for Mac OS because the Mac operating system doesn't have those base kernel features to pull off containers. So when you run Docker for Mac, which many of you may have already done that in the past, what actually happens is it installs a super lightweight hypervisor-based VM that's running a custom Alpine Linux distribution. But the experience that you get working with Docker for Mac or maybe Linux containers on Docker for Windows is that it's almost exactly the same as if you were just running Docker on a Linux machine. Now, Are native Mac containers ever going to be a thing? Probably not, because who actually runs things in production on Mac? Maybe if you have like an iOS build server, but that's like pretty much the only reason you would use a Mac server in production. So alongside with containers, another super important concept when working with Docker and containers in general is an image. So who here would like to take a stab at giving a definition of what is an image?
What you hope to run in your container is a complete set of definition of the app or instance that you find to execute.
Yeah, that's a pretty
Yes.
it's a pretty complete definition of what is an image. So an image in Docker is a read-only template for creating containers. So an image, very similar to or analogous to like a VM image or an OS image, a container image describes the dependencies that you want installed in your container and the environment that your container should run with. It can, doesn't have to. Good question, yeah. So we can say that a running container is just an instance of an image. So it's like a cookie cutter or a template almost for creating containers. Now, the value of images is that containers existed before Docker, but Docker came up with this concept of an image, and using container images made containers much more portable, and that's really part of what made Docker and containers catch on so well. So it's a little bit confusing to keep containers and images straight at first when you're using Docker, but you can think of it as, okay, we build images and we run containers based off of those. So images are a build time construct and containers are a runtime construct. Now you can or don't exactly have to put your source code in there. Maybe you do, maybe you don't want to in different cases, and we'll look at a few cases where you do maybe want to put your source code in your images, and maybe other times where you want to leave it out for the time being. So Docker images are built from a special file called a Docker file, which is pretty much just a simple text file that's got a special syntax, and in each line runs a command. It makes a change to the file system. Can you guys see this all right? Okay. Looking back, I probably shouldn't have made these slides dark. Oh well, that's 2020. So I'll quickly run over kind of the basics of this Docker file right here. So any Docker file is going to start with a from line. So you always need a base image to start off with. So in this case, my base image is an Alpine Linux image. And then my next line here, so each of these lines here are making some change to the file system of the image or adding some metadata to the image. And when we build from a Docker file, each line of the Docker file creates what's called a layer. And we'll talk about layers in a minute. So it's pretty simple. We can just, this is a simple example of maybe a slightly naive example. So the first thing I'm doing here is just, okay, I'm just installing node.js, that's it. And then next I am going to do a global install of Calce. Does anyone ever use Calce? Super, super important library. If you haven't used Calce, you need to check it out. It's probably saved my life. Next, I'm just going to do a simple, okay, make directory command. So I can set my working directory to this right here. This special worker command that just says, okay, any other command or instruction following this is run relative to this path. So pretty much before, when I was running all these up here, I was doing this from the root level of the file system. But now, when I run all the following lines, I'm actually doing it from inside opt/app. So right here is a really naive way of copying in my source files. You really don't want to do this for real, but it's a good enough or simple example for now. We'll see better later. And then I'm just, okay, installing my dependencies. Right here, I'm saying, okay, well, I know that my app needs to be served on port 3000. So I'll go ahead and document that right here. So this line actually doesn't do anything special. I can connect to the container from outside the container over this port, but the value of adding this exposed line is it just kind of documents for myself and any users in the future that, okay, if you're running a container based on this image, then you're going to need to publish that port. And we'll look at what exactly publishing the port means. And then it's best practice to always specify kind of a starting point or an entry point for your image. This one right here is just, okay, whatever npm start does, so probably starts in the server. There is another command you can use called entry point. The difference between entry point and command is much easier to override at start time. You can override entry point as well, but entry point is kind of to document, hey, like, you can start other processes in this container, but you should probably just only use this one because that's what this image is built for. In this case, I'm using command because there are cases where you want to be able to run, a couple different things inside of your containers. Now, and it's really fun. In a previous talk, we dug around in the underbelly of Docker and looked to see kind of how those images are stored in the file system. That's really, really fun, but there's not time for that tonight. But I'll encourage you to do that on your own later. So images and layers. So layers is a super important idea to grasp when working with Docker images. So what Docker does is it uses what's called a union file system. And all these different layers are really just stored as different directories on your host in some deep, dark directory that Docker manages itself and that you shouldn't touch in practice. And so what happens is when you start a container, it takes all those images and mashes them together and presents that to the container. So what the container sees is kind of like this unified file system. The container just sees, okay, a complete file system, doesn't really care about images. But the value of having storing these images in layers is that the image itself in each layer is read-only. So that means if you want to start multiple containers in the same image, you don't have to have multiple copies of that same image. They can all just read from the same thing, so you're not having to store as much. And then, same thing, you might have multiple images that are all based on the same starting point. So in the previous this example here, I was starting from Alpine 3.6. So I might want to have multiple app images that all start from the same point. Well, in that case, I only need to install the Alpine 3.6 image once, and then all those additional images that I'm building can just be based off that one. And so it's just a much more efficient use of the disk that we have available to us. Now, there are times where a container is going to want to make some changes to the file system that it sees inside the container. So each container gets its own read-write layer. So this layer is pretty much the same concept of these layers down here, except it's unique to that container, and only that container has access to it. And any change that it wants to make down here is actually persisted up here. And then the union file system, again, does the work of mashing all that together so the container still has no idea how all that is stored. And changes are only persisted so that a single container can see. So super important. And so storing images with layers like this really gives us a lot of benefits. The last major benefit from this is if you, in a lot of cases, you're going to have to rebuild an image. Anytime you release a new app or just even change the version, it's probably a good idea to go ahead and rebuild the image. Well, if you've already built most of the image from the previous time and nothing going inside has changed, then they can just say, oh, well, Docker can look at all those layers and say, oh, well, I've already built this, I'll only rebuild it. And rebuilding the image is just like that. So for example, maybe you're sticking in your package.json and then after that running npm install, and then after that putting in your source code. Well, if nothing's changed in your package.json, then that means, okay, nothing's going to change with the npm install command. And then that way, maybe you had some change in your source code that you're sticking to the image. Well, then from that point on and the rest of the layers, you'll have to rebuild those. But you're not having to redo that really expensive step of installing all your dependencies. Now, in case this idea of image layers is a little confusing, I want to step through a quick illustration of what this looks like. So from the Docker file example, if I'm starting off with an Alpine image, my file system might look like this. And this is kind of a dumbed down version of the file system, but it's going to have these directories and a few more. So this is my starting point. Now, the next layer was I said, okay, let me update my package manager and then go ahead and install node.js. So that layer is going to look something like this. Down in user local, then I have node installed, and then my node module and npm down in user local root. Next up, when I install calseg globally, that's also going to end up in this global node modules directory where npm is as well. Next 3 lines, these are going to be executed separately, but just for the sake of the illustration, we're going to look at them together. The net result of these 3 lines is, okay, we've created this app directory right here, and then I've put my source and package.json and my yarn lock and anything else that came along with this command. We'll talk about what this is exactly later on, but essentially, let's just assume the net result is this right here. Next, I'm going to install my node modules. So those are going to end up in the node modules directory inside of my app directory. Now, and this is the last step. Now, each of these things are stored separately on the Docker host. But when the container sees it sees something a little more like this. It sees this unified file system that's, has everything it needs to run. And it kind of matches everything together like that. Before we move on, any questions about containers or images? Good? All right, cool. I want to point this out real quickly. Actually, before I go there, I want to just look at a few, 2 simple examples, just so we can kind of kick the tires a little bit. Docker. So, for the first example, got to keep all my screens straight. So I want to just do 2 quick examples. So for example, I'm going to run a container. So I'm going to say docker run -it. Give my container a name. I'll call it Ubuntu example. The name of my image will be Ubuntu, and I'll start it off with a batch process. So what that's doing here is simply run a container. These 2 flags right here, I have interactive. T is for terminal. So the interactive flag makes it such that the container will read from the stdin of my running shell. So any commands I give on my keyboard will end up in the container itself. And then the T kind of gives me this pseudo terminal right over here. And if we look inside, it kind of seems like we're in an Ubuntu instance just like that. I mean, you see how quick it took like maybe a second to start that up. But there are some differences with being inside of this container versus being on a full-blown Ubuntu distribution. So for example, if I run PS, I only see just 2 processes here. And this one's already exited. So really there's only this one process running. So Linux containers typically, you can run multiple processes, but it's typically best practice just to run one process per container, which makes it super, super lightweight. Now, it also doesn't have as much installed as I would expect from a clean Ubuntu distribution, right? So I don't have Vim, I don't have ifconfig, I don't have man, right? So because the typical use case for containers is to run applications, and in most cases you don't need to be running Vim or ifconfig or man inside of your container. You can install those things if you want, but this base Ubuntu image doesn't come installed with a bunch of extra crap. Real quick, just to kind of demonstrate the copy on write concept. So if I echo some text into this text file, right, and I can see that it's there. So this change right here that I made to the file system, that change is persisted on that read-write layer that's unique to this container. And then if I wanted to, just for fun of it, just crash the bin directory. Oh crap, I guess that's a problem. That change also is persisted only on that read-write layer of this container. And it doesn't actually trash the bin directory that came from the image. It'd be an awful thing if it wasn't, because then all the other containers would be like, crap, where'd my binaries go? And that would not be a nice thing. So I'll exit out of that. One more quick example is I can do Docker container. Always hard to spell things, right? Run -p, and I'm going to say 8080 80. We'll talk about what that is in a second. I'll give this container a name. I'll call it web server, and I'll start it off with Nginx image. Right here, what this does is the -p flag is short for publish. So that's publishing port 8080. Port 80 in the container to port 8080 on the host. And essentially what it does is that says, okay, any network traffic on port 80 on the host is redirected to port 80 inside the container. And doing something like this is pretty typical when you're using applications to actually talk to the outside world, which is, in most cases, you want that to be the case. So I'll start this off real quick, and I will go to Safari, or my browser. Escape, there we go. So I will go to localhost. Localhost 8080. Awesome, and there we go. So just simple as that, I was able to connect to that container, and then if I wanted to, I could come back over here and kill it just as easily. And if I refresh over here instead, and I can very easily Docker restart web server, and it's back up, simple as that. So starting up containers, turning them down, super quick. One couple of quick things, real quick. So there's this thing called Docker Hub, which is essentially like GitHub or NPM for Docker. This is where you can get a bunch of images that are pre-built, or you can build your own images and put them up there. You can find like official images, like Linux distributions, or maybe images that already have like node.js or .NET pre-installed. And those are typically maintained by core maintainers of those projects. So and any time, like when I ran that Docker container run, a YouTube example or Nginx, those images came from Docker Hub. And typically, if you don't already have them installed, when you want to run those containers, Docker knows, okay, let me go and pull that down for you before I start the container. So definitely really useful. And last thing I want to talk about, make note of in regards to Docker is, in JavaScript land, we're used to having a lot of churn and things always changing, based on what's cool for the week. But the container world has really matured a lot recently. And so now there's this governing body called the Open Container Initiative, which kind of oversees the development of and the standardization of containers, which is really nice because there's people from Docker, there's people from Red Hat, Google, Microsoft, people from the Linux Foundation, all involved in this and creating a lot of container standards. So they have a container runtime spec and a container image spec. And that's great for us as users because that ensures that we can place our bets on this thing and we're not going to be upset about it a year from now. This has nothing to do with Docker. I just wanted to show this. So if you have nothing else for the night, I hope this inspires you. All right, so I want to talk about managing dependencies with Docker. I've been talking a lot. Talking will end shortly. So I think we've all had days like this, where you can't, for the life of you, get all of your node modules to play nicely together, and you just waste all of your time when you should have been like building some new features. You instead are fighting with NPM or whatever other package manager it is that you're working with. And similarly, onboarding with a new project is typically a pain. I remember when especially when it's like cross-platform, maybe like JavaScript in the front end, .NET in the back end, and a whole mix of other things. I remember having lots of struggles gearing up on a few projects myself. And Docker can really help us ease these pains. Now, we have a lot more dependencies than we realize, I think, as JavaScript developers. So as JavaScript developers, especially when you're using Node, our operating system is a dependency. Your C++ compiler is a dependency. System libraries are a dependency. Because there's a lot of node modules these days, for pretty much a while, that depend on binaries built from C++ code. And so those things have to be compiled, and if you don't have your compiler set up right, then you're going to have a heck of a time trying to get everything to work. And I've gone through days where the C++ side of things of Node.js was not working, and that's just not a fun place to be. And then, of course, your Node version, your NPM version are also dependencies that either help us or harm us. And then we also have CLI tools. We have, some of us may have a whole host of globally installed Node modules that help us. For example, maybe one project might need a update of the whatever database driver that you're using. And so that update that's required for one project might end up breaking another project. And I don't think that's an outrageous example to think of, because I know that's happened to me personally. That might have happened to you guys before. And then there's also the case where maybe you add a dependency and you don't tell your coworkers, and then when they install it, they're like, this crap doesn't work. And you end up wasting your time trying to figure out, okay, why is this not working? Because they just didn't tell you. But if we're all honest, I think we'll agree that we've been on the offending side of that equation. No, I have. But what it comes down to is that different projects require different versions of the same dependencies. That's good. I'm going to repeat that again. Different projects require different versions of the same dependencies. And not only that, but same projects require different versions of the same dependencies over time, which is even more painful. While I'm at it, apart from using Docker to manage these aches and pains for us, it seems like these days, every month when a new CLI tool comes out for Node.js, you read the docs, it's always like npm install -g this thing, and we end up having all this crap installed, and before we know it, we start to depend on these things for different applications, and then different applications start working well with some versions and not with others, and we get in a real mess. And I'm not opinionated about a lot of things in software development. I'm not even going to be opinionated about anything I say about Docker tonight, but I will die on this hill. You should think twice before you ever do this, because you can very easily get access to the same CLI tools just by installing them in your local project and then access them via yarn or npm scripts. And then each project has its own version of whatever CLI or build tool that it needs, and it's not relying on any global dependency. I mean, CalSpeak is still fine. Please install that globally, but nothing else. CalSpeak, that's right. So what are a few solutions to this problem? Probably can see that very well, but this is the npm please command that's missing from npm. When things don't work out, you just trash it and reinstall. Sometimes that works, sometimes not so much. If you get desperate, maybe you'll just back up, just nuke your repository and reclone it and hope that does some magic. I've seen some people advocate for this. I will also be opinion about this. Please don't do this. There's so many problems with this. One, you're going to end up with a ginormous Git repository. And then secondly, especially if you have binaries that your node modules depend on, those are going to be built for your OS and architecture. And if you have coworkers or contributors that are working on even a slightly different operating system architecture, this is going to mess them up like crazy. So please never do this. And then secondly, whenever you, if you have a version change in Node and you have all these old dependencies that you committed a long time ago, whenever the Node version changes on your computer, Node's going to start complaining about these things. So please don't do this. There are some pretty decent solutions. So these days you can actually install a Node binary for each project, which just makes Node modules even larger than they ever have been, but it works. There's also the Node version manager, which I think is a pretty popular solution. But this only solves the problem of node version between applications. You can still use this to make sure that you've got the right version for each app running on your computer. But we still have a whole host of other problems with the node modules themselves and a lot of other things. So I've done a lot of talking. Let's take a look and see this in action and see how this actually works out. So if you happen to clone any, I keep on switching my screen down here and not switching the screen up here. So if you happen to get any of these examples, we'll look at New Year's resolutions first. So let's take a look at here. You see node modules right there. I'm actually going to get rid of those. All right. Now, what I've got here is a setup where I can run this project locally without actually needing those node modules installed, because I built an image so that they're installed there, and I can just run my app locally from a container based on that image. So let's test it out and see how it works. So everything seems fine so far. Dev server is kicking off. Awesome, finished. And let's go over here to the browser. Localhost 8100. And it works, awesome. That is not that exciting. It's almost a glorified to-do list. I'm not going to talk about a cool app. We're here to talk about that. Which is pretty cool. Now, what's even cooler about this setup, so I don't have any node modules installed locally. So that's a great benefit, because if all the developers on the same project are working from the same base image, it guarantees that they're running the exact same version of Node. They have the exact same version of Yarn that installed those dependencies. They have the exact same dependencies that were installed. So even this simple setup that we have here really helps move us away from that, well, works on my machine problem. Now, and also the benefit of this is that, you know, learning Docker might be scary for some developers on the team, right? So you might have multiple developers, and as long as, you know, just one of those developers knows Docker, you're pretty much straight, because if you're only using this for development, which is right now at work, most of what we do is just for development, you know, Docker kind of sits nicely under the hood, and really, unless something goes terribly wrong, the other developers don't really have to even worry about it being there. They can just continue their workflow mostly as normal. So let's take a look at the image that we built for this. So this is a better example of a Docker file than what was in the slides. Now, this particular image was built specifically for development. Usually, you're going to have a different image for production. And we'll talk about the differences with that. So basically, just blah, blah, some metadata stuff. I'm starting off from a node.js. This is an official image. And I'm using this version of Node, and it's based on Alpine. So there's quite a few different flavors of Node images you can find, but the one based on Alpine Linux is the smallest as you can get. And it's no surprise that the smaller your image is, the much quicker your workflow is going to be. So if you've got to share images, you've got to push to Docker Hub, pull from Docker Hub, it's much quicker. So always want to keep your images as small as possible. And a lot of language runtimes these days that have official images out there on Docker Hub are including an Alpine option. So it's maybe not always the first place to start, because sometimes it's a little bit hairy getting things to work right, but if you can get there, definitely improve it. Next, I'm just simply setting an environment variable. So this is the same as saying export node environment is equal to development, calling it a shell, and then that environment variable persists whenever I start a container from here. This guy right here, I'm doing a few tricky things. Now, you see I'm running multiple commands here. I can run these on separate lines. So I can have a run line for this one, a run line for this one, a run line for this one, and a run line for this one. And that's fine, but it's typically best practice to, as much as possible, and as long as it's not an impediment, to keep as many commands in the same run instruction as possible. Now, you wouldn't necessarily want to include an npm install in something like this, because this is okay, like just getting things set up. So like for this image in particular, I'm installing an FTP client. This is actually stolen from one that we use at work, and then we actually use that image in our CI process, or in our CI pipeline. And after it builds the code, we just use this FTP client to FTP the built JavaScript HTML to the server. So I'm actually using this for the example, but for sake of having a decent example of the Docker file, we'll look here. And not only are we combining all these in one line, but if I know, like, I don't need to, like, reinstall this later, I'm going to go ahead and actually clear that cache. So I gave it no cache. Even still, there's directory sets up. Okay, I'm going to clean up as much as possible after I get things set up, just to keep my image small. We've seen this here before. And then down here, I am adding package.json to my app directory. And then yarn lock, and then I'm doing the yarn install. You can also do copy. Copy and add are essentially the same thing, but add can add from remote sources, where copy is only adding things to the image from the files that you gave Docker access to. Now, you'll notice, this is a key thing here, you'll notice I'm not adding my normal package.json here. I'm adding this special package.json that I'm pulling from this Docker directory. We'll look at that in just a second because that's important. And then I'm exposing these ports because I need to have all three of these running, or all three of these open for the dev server to work. And then I start off with yarn server. Now I want to take a quick peek at this package.json file because it's very important. So if you look inside here, I have just a simple description and my dependencies. And that's it. Now, when you're building images, you're working with Docker files, if anything on this line up here, so if anything had changed in my package.json before installing my dependencies, then this line would have to be rerun. But if all this is the same, then I don't need to reinstall my dependencies, and it makes rebuilding this image super, super quick. Now, you might be wondering, well, why did I do it like this? Why can't I just use the normal package.json? And bonus points if you're wondering that. Well, let's take a look at a normal package.json file. So in this case, I've got all these scripts, I've got some config stuff, and my dependencies, and I've got all this metadata up here. Now, building a Docker image is all about getting my dependencies right. But there's a bunch of crap in here that has nothing to do with installing dependencies. So that means, okay, if I just use this package.json file and added that, just the normal one right here, and then, well, imagine what would happen if maybe I added a new script, or I just changed something in this section. Well, then, because of that change, it would cause Docker to have to rebuild this layer of the image, even though my dependencies didn't change. So what actually we do is on every version change, so any minor, major, or patch, this stripped down version of package.json is regenerated, and that's what's used. And then we rebuild the image on every version change. A couple quick notes. Yeah, so also notice that two last things. I'm keeping the things that introduce the most entropy. I want to put those as far down to the end of the Docker file as I can, right? Because if I do my npm install or my yarn install first, that is what I would expect to change most. And then when that changes, everything else has to be rebuilt, right? So if I did this last, well, that means this has to be rebuilt anytime that my dependencies change, right? But I know, well, if these have no dependency upon my node modules, then I'll just keep this taken care of out of the way first. I know I'm not going to change the version of this hardly ever or probably never, so it's safer to put this first, and I'll rebuild this as few times as possible. And I'm not doing anything after my install. Now, I could put source code in an image, but in this case, I'm not. Yes, sir.
So the Docker package JSON is have the same dependency with application path.
Yeah, the same dependencies. All I do is whenever on a version bump, I've got a script that will take the current version of the root level package.json and just takes out everything except the dependencies, and then it saves that in the Docker. Yeah, so that's always going to stay the same. Now, you might be wondering, well, how am I running my application code if I didn't put any source in here, right? It's a great question. So bonus points if you're wondering that. Let's take a peek at how we started this. Now, you can run containers from the Docker CLI, and the Docker CLI is a great tool to kind of play around and get familiar with things. But in normal, like day-to-day workflow use cases, you don't want to use that because you're gonna have to be typing a lot of the same commands, and it's gonna get repetitive and a waste of a lot of time. So Docker has this really cool tool called Docker Compose that can kind of abstract and kind of run all those same things that you would do in the Docker CLI, but from a config file. And that's checking the source code. So a few things here. So this is just like my Docker container run. I'm starting with this image. I'm exposing, this is publishing these ports just like we did the -p 8080 to 80. So the same thing here. This is allowing, I can either set environment variables here. So I could say example.com, or I can just leave it like this, and this actually allows environment variables from my current shell just to be passed straight through into the container. You might want to do that, and definitely don't want to do that for production, but for development, that might be helpful. So we have that here. I'll come back to these because this is super important. This is kind of repeating for the sake of verbosity what we're doing, and this is something else. We'll talk about that. So this is kind of a super important part of my development image and my development container. So what this does, this volumes right here, again, you can do this from the command line, but this is much easier to do it from a config file. This says, okay, you know what? When we start this container, we're going to take app.config.js, which is right here, and plug that into the container at this point, right? We do the same thing with all these config files, and all these config files in my webpack directory. And lastly, so I do that with my source files. Now, the value of that is I can just keep my image for development focused on having those right dependencies. And then, when you're developing, these things are going to change a lot. So you don't have to rebuild your image just for these things, right? You want to be able to plug these in, and you want the changes to be picked up as you're developing. So you can actually, even though it's running inside the container, since I plugged in my source and I have a watcher running inside the container, it'll pick up any changes to my source. So let's go over here, change this title to Docker is, definitely not how it is. Please no. Docker is cool. Geez, I can't spell. And you should learn Docker. So notice I made a change on the source files that look on my machine, but since I plugged those in to the container, the development server picked those up and it reloaded, which is pretty cool. So that's definitely super awesome. I love that about Docker. Now, before I move on, any questions?
Random question. What does your message say about Monday? That's under that modal.
Oh yeah, so it's part of the app.
I just saw Monday. I'm like, what?
Yeah, so it just puts out. Yeah, it's just like random quotes that go in the back. Yes, it's a cool app, right? Random quotes. Okay. Any questions about this setup? We're gonna go into some more detail about it. Any questions before we keep going? Yeah.
How you are detecting the change?
So like the development server has a watcher on those files, right? But since those files from my host are shared with the Docker container, the Docker container sees those changes. Any updates that happen on the host happen in the container and vice versa, right? So yeah, you can give read-write. Like in this case, I just gave willy-nilly read-write access. You can control even those permissions. All right. So there's a few concerns that you might have if you had such a workflow set up. So, for a developer, like maybe you want to add a new dependency, right? So we'll go over here to the command line. We'll stop this for a quick second. And maybe I want to add pirates. So what we can do is we can say add pirate. Hold on. Okay, make sure I'm doing the right thing. It's always important. Okay, that's pirate speed. Pirate speed. This is pretty much an abstraction of, okay, lift up the covers of that image, stick in a new node module, close it back up, and that's what we're going to use moving forward. So I can very quickly do that. And this is all happening inside of the container right now. It's not actually happening on my machine. It's pretty nice. Then it updates the version of the image that I'm using. Awesome. Look over here, that updated this to the latest, which was the image I just recently built based on that container. And now, so notice, still no node modules. You can come over here, and I will say import and we will these two pirates speak. Why not? Every cool we have needs some pirates. Cool. And all the while, still no node modules. So we go back over here, and I will say yarn start again. Oh no! Oh, hold on. Ooh. Well, oh well. It didn't work last night, so of course the demo gods would be after me. So it does work though. That's all right. So
yeah, you got a lock file there. So it's probably good.
okay. Well, I'll work on it later. You can take a look at it later. But it really does work. I swear. I swear. All right. And so another great benefit of, let me check out right here. Another great benefit of using this workflow is, so the same project might have multiple different versions of the same dependency over time, right? So let's say I've got like super old version here. So let's check out version 0. And maybe this is old, long time. It's been in production for a while, and there's still some users on this old legacy version of managing their New Year's resolutions. Now, I look at my package.json here. My Angular version is 2. And my current version on dev, Angular version is at 5, right? So if I had to switch back to fix something old, make that change, then go back to the current version, you've got to keep on installing and trashing node modules, and that's just a pain. So again, that pain is resolved. So let's say, I've got to go fix some fog back here. Some users complained about some unexpected behavior happening in the application. You pull that down, check it out. Just as simple as that. And let's check out what the project is. Oh man, if we look down here, some cheeky developer thought it would be fun to stick a dancing banana in the application. I don't think that was very considerate. But I could go in there, get rid of the banana, make the change, then just switch back to the current version I was working on. Let's see. So yeah, a couple downsides to having this kind of setup is, well, you don't get language support, and at least not in VS Code, because VS Code needs to look at the locally installed in modules. I'm confident there's a workaround for that. I just haven't taken time to figure that out. So you could at least still install your node modules, at least just for that sake, even though you're not using them. And you'd be pretty safe, but I feel like there's some novelty in running your node applications without actually having node modules on your machine. And you still, at least how I've got it set up, we still need some node modules installed to run some of these development workflow tasks. And again, that's not the end of the world, because it's not actually what's going to production, but still it'd be nice to have absolutely no node modules installed. Are we doing on time? All right, cool. I want to real quickly go over the script right here. Take a quick look at this bump script. It's pretty simple. So anytime we change the version number running this script, and all it does is it goes through and update the version number. We're bumping that version. Before we actually bump the version, we check to see if there exists a git tag for that version already. If not, then we just kind of abort the script, because the next step is we're going to end up building a new image that's tagged with that version. And if someone else has already built it, then I don't want to like rebuild it in Cloud or whatever they did, right? So we have this kind of safety check in here. And then we go through, and any reference to that version number, whether it be like a config file or my .compose file, is updated to that new version. And then we also, down here, somewhere, we copy, this is the step that strips out all of the dependencies from my package.json and makes that specialized stripped down version. And then we go through and we commit and tag all those changes. We build Docker image and push the Docker image. And then lastly, we push all of our changes to source control. And now, there is still kind of a dangerous zone here where, okay, maybe someone, you check here to see if there exists a tag already. There is some danger in that, okay, at some point maybe someone can beat you to it. They can push that new tag here, and then y'all end up overlapping with each other. Small teams is not really a problem. You can still go back and fix it manually. And then really in practice, so like, we use this for development at work, but we're a small team. So if you had a huge team, you could always build your images as a part of your CI pipeline. Use something like Travis, something like that. And the reason why we do git push last is because we can actually reuse the same image that we're building for development in our build process, as I mentioned before. So we use Bitbucket. So we also update the base image that we use to start off our Bitbucket build. And pretty much just for each branch, it'll go through and rebuild starting. And the value of this is this build script here doesn't have to waste time reinstalling build modules, because I already have them from starting off with this image. We started doing this at work, and it cut our build times down pretty much in half. We use Angular and Ionic, and the builds are a bit slow sometimes. So it was nice to kind of shave off 3-4 minutes. Now, all this is nice, but it's not, admittedly, it's not a very significant example, because it's just a simple client application. There's no backend here. So let's take a look at a similar but more advanced setup, but for a full stack development environment. Now, this is the part where I would like to have a volunteer. So does anyone want to come and volunteer their computer and be a guinea pig for me? Anyone? Or you've got to have Docker installed, and you have to have cloned this repository at the beginning. Anyone want to come?
Mike,
All right, you guys are gonna have fun. I've done this 2 times already, and everyone was like excited to come up, but that's all right. I'll just be my own volunteer.
Okay, going back.
Yeah.
What was the IDE for development?
Great question. I'm glad you asked. We'll look at that in about 5 minutes. Of course, for like front end, like, it's great, right? But great question. Let's on top of it. All right, so let me go back here. Do it myself. You guys in this one. Back up here. So I've got this repository that has a couple different submodules. So I've got an API, I've got my client now, and then I've got a special Azure's function app. And I want to be able to run all this locally for development. So the API talks to a MongoDB database, and then the Azure function just gives us random quotes. It's not very significant, but it works for this example. So let me, you know what? Just for fine. Let me just use that. Actually, not only that. Let me just to make a point. Clone this fresh. New example. There. Oh, I can do it. There we go. So I'm going to get submodule. Awesome. Get submodule. Submodule. Fantastic. All right. So all I did here was I just cloned my repository, just got it fresh. I got the submodules, and I'm going to say yarn up. Docker is working a bunch of magic behind the scenes. Oh. So I have stuff running. Note to self, next time I need to make sure I clean up all of my playing around stuff before. Should be good. This guy is using. Oh, geez. So the problem is this port's already being used, and my slides are also running in Docker. So I'll kill this for a second because I need 20,000. So Docker here, remove. Awesome. All right. Now, okay. Ideally, you wouldn't have slides running on the same port you need for development. Now,
You had volunteers.
I know, right? Jeez. So now I'll say yarn up, and it's doing all this fun stuff. And I see lots of pretty colors. It looks like everyone's happy. Let's see. I've got my Azure functions container. MongoDB started up. It's fine. Functions are fine. My app started up. That's nice. Everyone's happy. Awesome. So I will go back over here to 8100 and I'll refresh. Just like that, I have all parts of my full stack application running locally. I didn't have to do any installing. I didn't have to do any configuring. I just clone this stuff, yarn start. That's it. So, because I've been in projects where okay, I've got to start off, but I've got to find a database file from on the interweb somewhere. I've got to import that first, and then I'll work with .NET on the back end. So then it's like, okay, well, I've got the wrong version of IIS, I've got to update SQL Server, blah, 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 all this stuff. Same thing in JavaScript. And notice I actually have some default data here, which is really, really nice. Now let's go back and take a look. And I've got my compose file set up in the same way so that if I make any changes in my client code, in my API code, or in my function code, then the respective container will restart the process so that I get my fresh changes for development. It's pretty nice. So let's see, a couple things I want to do with this. Yeah, so first thing, just to make this proof of point, go back over here, and I'm just going to add a quick thing I'd like to do in the new year. I'll eat more bananas, great. See, it went there, that's great. Now, I'm going to kill this guy. I'm going to actually shut all that down. And I'm going to start that back up again. Now, the thing with containers is containers are persistent, but they're ephemeral, right? So any changes you make inside the container are going to be persistent inside the container, but only as long as the container is alive. Containers are meant to be throwaway things. So if you have anything important that's inside the container, you need to do whatever you can to get it out. Whether that's, okay, you plug it into a volume or you send it to, a database somewhere. So in this case, if I am developing an app and that app depends on data, well, I don't want to start from square one anytime I pick back up with development again, right? So in this case, I was able to, add some data, go kill all that stuff, start it back up again, and I'm going to refresh and see if my data comes back in. And here's that new one that I have, which is awesome. So there's a couple ways we can pull this off. Yeah, so there's a couple different things that we can deal with this data. First, let's look at in order to get that seeded data, there's a couple different options we have. You can just run a script either inside the container when MongoDB starts. You can run a script from inside of the API container before it actually starts serving. In this case, I decided that I wanted to save my seed data as a part of the image itself, because that would just make it super, super simple to set up. So that would guarantee that when I start my MongoDB container, I know I already have data. And I mean, all I did was I just said, okay, well, I'll start from an official MongoDB image, and I took data from my local file system and I stuck it right here. I know that MongoDB is expecting its data to be here, right? So if I put my own data here, then that I generated from MongoDB, then I know that, okay, I'll be able to start up my container with this image, and I already have the data in place that I need for running my application. Now, this guy asked a great question. So you're running this inside of a container. What about debugging? So good news, we can still use our VS Code debugger from inside here. So I've got this debug config set up. Right here is where the code is from the API, and this is where the code is inside the container. And if you look back at how we started the API, yeah, so we started with this expect flag for port 5858. So using port 5858, we can debug, right? So let me go ahead, I'll put the debugger configuration here. I'm going to go ahead and get that started. Looks like it's all fine. Let me go here. I'll add a breakpoint to this line. And I'm going to issue a request for Postman for simplicity to get all. And just like that, with that thought, I can very easily go through here. Go that far, but I'll do it all over here. So I can do that. I can see, okay, I've got stuff here. Yeah, well, whatever. I always have a hard time with promises and sticking your breakpoints to the right place. I'll try one more time. You know what? Let me I'll put it here. And we start that debugger. Be able to see the people that I have. Oh well. You don't want to watch me fight through my node.js debugger. Oh well. But you get the point. It works, which is, I think that's pretty cool. A few months back, I wasn't even sure if this was possible, but people have been doing this for a while, so it works. Just forgive my debugging skills. A few other things I want to go over. So let's take a quick peek at the compose files and the images I use to pull all this off. So inside, I find this compose file to be interesting. So right here, the compose file, you define services, which are simply, I've got my New Year's API service and my New Year's Mongo service. Essentially, it's saying, okay, create a container with this configuration, create another container with this configuration. So a couple things going on here. For the API container, just like we did with the first example, I'm plugging in my source and my package.json because I've got some NPM scripts I need to run, so that's cool. I'm exposing these ports to be able to listen for requests and for debugging. Got this network that it's running on, which is interesting. I'll come back to that in a minute. And also, I'm plugging in this environment variable so that it can talk to the MongoDB container. Interestingly enough, the host name is right here near Mongo is the same name as the service right here, which is pretty cool. So notice I created this network down here. By default, when you create a network like this with Docker Compose, it creates a bridge network, which is just a local network. And with Docker, when you put multiple containers or services on the same bridge network, that provides automatic DNS resolution between containers so that they can just refer to each other by name, and Docker will handle all of the networking requests properly, which is awesome. Because each container does get its own IP address on the local bridge network, but that IP address is not going to be consistent each time you run. So you want to have something consistent that you can include. Another interesting item. Now, right here, this port publishes port 27017 from the container to port 27017 on the host. Now, I don't have to do this. I could not even do this, and the MongoDB container and the API container can still talk to each other. But the value of doing this is I can come over here to my MongoDB client, and just as if, so just as if I had MongoDB running locally on my machine, I have it set up here. So same setup I'd use if I had MongoDB running locally. I can connect that, and here is my database with my collection. And there's all my data, which is pretty sweet. So from the host machine, so by exposing that port, I could take a peek at all this data that's inside of my MongoDB container, which is super, super helpful for development. One other important piece from this host file here is this guy right here. Now, I want the data that I put inside of my database to be persistent. At the same time, though, now I could just stick it on some random place in like my file system on the Mac. But I feel like if I did that, I would like replace it, accident, or like misuse it. I'd lose it. I'd accidentally delete it. Now, what I'm doing here, is I created this special volume. Now, this is a Docker managed volume. So instead of this living on my host machine, this actually lives inside of the Docker VM that's running over here. Now, if you're doing this on Linux, it would just be on the computer itself, but still it'd be kind of in a deep, dark place that Docker can manage for you, which is super helpful. And then here, I set up the type of the volume as a volume. This is my source, which is this guy right here, and I want the contents of this directory in here to be saved into this volume in Docker. So this directory in the container. And what's really, really cool about this is when I first get this going, this volume isn't going to be created yet. Now remember, I already put some data here inside of my MongoDB image. So if this is a fresh volume, what happens is the contents of this are actually copied into the volume. So that means I can start off with that data. But it's not going to overwrite. It only does that when the volume is first created. So it's not going to overwrite any data that I've put in since then. So that's super cool. Any questions about that? All right. We'll look at one last thing. I want to take a peek at some of the images I'm using here. I'll give it the client because that's probably the most interesting in terms of images. So this is pretty much the same exact dev image we saw last time. Now the production image is quite different from the development image that I'm using for the client that I'm using. So over here, I'm just starting with a base node.js image. It's fine, and I'm running a node.js process when I start off the container on this image. But over here, I'm doing something a little special. I actually have typically, in a more trivial example, you'd only have this one from line at the beginning. So up here, I'm starting from a similar base, and I'm giving it a special name. And I'm doing, some pretty simple stuff, making some directories, putting my stuff in there, installing, adding my source. And then I'm running this command so that I can build my code for production on the browser. Now, after that, what I'm doing here is called a multi-stage build in Docker. So after that, I can pick a new starting point. And I want to use Nginx to actually, in production, serve those static files. So this is my new production image that I'm starting off here. And I can, instead of just copying files from my local file system, I can actually say, okay, you know what? Copy contents from a previous build stage from this Docker file. So I can say, you know what? I want to take these build files, which is the result of running this command right here, and stick them over here inside of this new image starting point. And the value of having a multi-stage build, you could have more than just these two steps. But the value of doing this is this becomes my image right here. And all this crap is left behind, and this stuff is trashed, which is great because you want to keep your images as small as possible, right? Because if I'm just serving some static assets for the web, I don't need to have Node installed for that. I just need a web server, and I'm using the Alpine flavor, so it's as small as possible. So in some cases, there's a vast difference between how you would build your images for development versus how you would build them for production. For development, keep it small, but you don't have to stress over it as much. For production, you better keep the thing as small as you can. And there's not so much difference with these guys. Major difference is that maybe I'm still going to have Node installed, but in this case, they're going to expose different ports, and they're going to start off with a different process. So we're wrapping up here. I think that's for this evening. That's Node. Yeah, that's pretty much what I want to share with you guys. I want to go over a few examples, a few quick slides to wrap up. Got to kill this so I can free up 14,000 from the slides again. So we will yarn start over here. Put that. Cool. All right, so just to wrap up, a few quick things. Yes, it worked. So what's next? So maybe this is your first look at Docker. Maybe you've been using it for quite a bit. I hope tonight has inspired you to kind of pick up Docker yourself and see what you can do with it. So, well, first off, if I were you, I would take the setup that I have here and see if you can work it into your own application. I'll be the first to admit the exact setup I have here isn't perfect. It's usable. I use it for my personal application. I've used it at work, but I definitely think it could be better. So I would love it if you guys wanted to kind of do a similar thing with one of your side projects and see how it goes. Maybe make some changes, and I'd love some feedback on, hey, I think this could be done a little bit better. So that would be awesome. Next, when it actually comes to using Docker in production, you don't use Docker Compose. You don't just use the Docker CLI tool. There's actually other tools that are designed specifically for running Docker in production. Because in production, you want to have multiple servers, multiple containers of, or multiple instances of certain images. So these are all examples of what are known as container orchestration tools that can help you. Kubernetes and Docker Swarm are definitely the most popular, but Red Hat also has OpenShift, and there's Apache Mesos, which is not primarily a container orchestration tool. It's actually a cluster management tool, but it has some container capabilities, and there are other specifically container orchestration tools that are built on top of Mesos. Like recently, Netflix came out with something they call Titus, and that's their own container orchestration that's built on top of Mesos. Are there any final questions, thoughts, or comments? All right, well, feel free to come talk to me afterwards or get in touch with me later. But thank you all so much for coming. If you want, you can reach me on Twitter at Hayden_dev. You can look me up on GitHub, and I'm also on the RVA Dev Slack channel. So thank you guys so much for coming tonight, and I hope you've learned something new from this evening.